Hello to everybody. I'm Brian Horner with the Etnyre company, and in Field 1 we are talking a little bit about Tack today. So let's talk a little bit about Tack. What is Tack? Why do we use Tack? Tack is one of those things that on a construction job that most people don't like. It's an incidental in most places, but in today's world, Tack has become very important to be able to keep our asphalts together, to glue those layers in between each other. Most people don't like it because it's sticky, it's gooey, it gets on your equipment, it gets on your feet, your boots, everything else. But Tack is one of those essential things that makes pavement that much stronger. In basics, it's just glue. And you will hear me use the word tack, you'll hear me use the word glue, you'll hear me use the words residual asphalt. For this presentation, all of those words can be interchanged at any time, because all we're really talking about is tack, which is the glue that we're gluing our hot mix together, whether it's one layer at a time or whether it's from the base to the top layer. So by using the glue does several things for us. When we're putting tack down, if you took these boards, for example, and you stacked them all up on top of each other and you jumped on top of them, they would slide and shift and move all over. But if we put a layer of glue between each layer, not only do they not move, but they become structurally more sound and more stable. So that's the whole purpose of this. No different in asphalt than gluing boards together. That's all we're doing, is gluing the surfaces together. Because if we don't use tack, especially in today's world where we're doing a lot of thin lift mill and fills, a lot of overlays where the asphalt becomes very thin, if we don't glue that top surface down to the bottom surface, we can get chunks that we call it delamination. They can blow out or pop out. Maybe in this instance, maybe the road surface was really dirty and we did spray tack on it, but then the tack stuck to the dirt and didn't glue the surfaces together, so then all of a sudden we have a failure. When we used to pave, 4, 5, 6, 8 inches thick, things didn't move quite as much. But the thinner we go, the more important tack will become. The other thing is slippage. If I'm not glued to my base surface, my mat can slide and move back and forth. I've actually seen several core samples of thin lift overlays that when you drill a core through all 3 lifts and the tack wasn't correct 3 or 4 weeks later, you could look down that hole and you could actually see that the pavement had moved underneath. That hole wasn't lined up anymore. So the purpose of the tack to keep that mat from slipping and moving. So what we really want in application is a uniform application of tack all the way across. In the old days, I've been around a long time, been in this business for over 30 years, we used to just be able to dribble some out, just sprinkle some out, and that was good enough. Well, in today's world, I always use the example of when I was a kid, used to make a Mother's Day cards, for instance, out of construction paper for your mother. So you take a piece of construction paper, and maybe the kids in the room that are listening to this don't remember those days because everything's done on the computer, but you would take a piece of construction paper, cut a flower out of it, and glue that flower onto that base paper, and then write Happy Mother's Day to it. You'd take it home, she'd put it on the refrigerator, proud as ever, but if I didn't put the glue evenly on those petals, after a little time, my petals started peeling back off of that paper. It's the same thing that we're doing with tack or glue in the asphalt industry. A good even coverage all the way across the surface will give us the best retention or the best stickiness. So look at the products that we use. What products is Virginia using for their tack coats? Well, we use emulsions. Is one thing we'll talk about today. We use a non-tracking tack, which is basically an emulsion that's made differently so that our trucks don't track it away and it stays where it needs to be, so we're not dragging our glue off the job site. And then some of the new ones are hot applied tacks. So there's 3 different types of tacks that are used. First one we're going to talk about is emulsion. So what are emulsions? Well, emulsions is a product that Mother Nature says cannot happen. You can't take oil and water and mix them. But in today's world, man says, yes, I can. So basically, you're taking a hot AC asphalt, you're milling it up into little bitty pieces, mixing it with some soapy water, and it's suspending that asphalt in that water. Then when we spray it, the asphalt stays as the water evaporates. So when the water's gone, we're left with what we call residual asphalt. So that's what we're doing. We're using the water as a carrier for our AC or our glue, taking it out to the road, spray it, the water and soap disappear, and we're left with the asphalt. There are two different types of emulsions, cationic, which are positively charged, or anionic, which are negatively charged. And what difference does that make to anybody? In this state, not a lot, because you're using all cationic emulsions. But if you travel to any other states and do work where they may use anionics, basically what that is a positive and a negative charge. You can't mix the two. They go together like magnets. So if you had stuff in your distributor truck, we'll talk about later, that if you had an anionic in it and you put a cationic in it, vice versa, they'll come together and they'll make a big thing of glue and muck, and it won't be good for anything. So as we make our emulsions, Virginia uses several different types, a CRS2, CRS1, or CRS1, a CRS2, a CRS1H, CMS. All of those, really all this means to you is C means cationic, which means it's positively charged. And then the R is for rapid set, 1 is the hardness, H is a little bit harder. All of that stuff really doesn't matter. Somebody is going to tell you on a job what is spec for that tack. And since we're dealing in Virginia with all cationic emulsions, you can mix these together with residuals in your tank and you'll be fine. You just don't want to take a half a load of that material and dump another product in on top of it. So when we talk about residual asphalt, that's what it's all about. Okay? It's the glue. If we don't have residual asphalt that's left to make our glue to hold those surfaces together, that's everything's residual asphalt. That's what we need to have. So if you look at your emulsions, remember I told you that they're water and they're oil, okay? Water and asphalt. Normally about 67% asphalt, 33% water. Virginia's not diluting any of your tacks. So however your asphalt is made will determine what your shot rate is to be able to give us the correct residual asphalt. Residual asphalt is crucial. We have to have it down there. So based on everything there, this is a bunch of words that just tells you got 2/3 asphalt and 1/3 water. So if you were shooting a hot applied material in years past, you really have to up your shot rate about 1.5 times to get the same amount of asphalt that's left on the ground after the water evaporates. So here's just a picture of it. If I'm using 67% asphalt with 33% water, we used to shoot a shot rate of like 0.05, which is such a small amount. Really, we're only getting 0.034 in my residual. So we have to really up that, and most of your shot rates now will be somewhere between 0.05 and 0.1 is what your state specs call for. But we're probably going to be closer to that 0.075, that 0.08 range, so we can get the right amount of residual that's left on the road. So here's just a picture of emulsion going down. If it goes down brown, that's a good thing. As the water and soap evaporate, it turns black and it leaves our asphalt or our glue in place. Coming out of the distributor, we'll talk about a little bit later, but if it's coming out pure black right out of that distributor, we need to get that material out of there, get fresh, and be able to use a little bit more, okay? Emulsion, one of those products going back to Mother Nature, who's gonna win the battle when the oil and the water comes apart, okay? So we want that to happen after we spray it. Emulsions also have a shelf life. They can't be kept too long, 30 to 90 days, depending on the type of emulsion you're using. You want to circulate them from time to time. You want to keep them at temperature. We don't want to take those emulsions and take them from 150 to 170 degrees and let them get down and cold. We'll talk about handling that a little bit, but in just a little bit. But we want to make sure that emulsion's nice and brown coming out, then it turns black after the water leaves it. Keeping them up to temperature is very important. Most of your cationic emulsions are going to be shot somewhere between 150 and 170 degrees. In my opinion, the warmer the better. That asphalt is hard that's floating around in that water. All distributor manufacturers use a gear pump. So the warmer we can make that tack, the easier it is to pump, the easier it is to circulate, the easier it is to clean the system out. So we want to take the recommended temperature and keep it up at its highest level. Emulsions, because they have water in, we don't want to boil them, because then the water leaves and we're left with the asphalt in our tank, and that's a big mess. We also don't want them to freeze. Okay? If they freeze, they'll do the same thing. Mother Nature will win that battle and she'll pull that oil back apart. So here's just some things on non-tracking tack. It's very similar. It's actually an emulsion in most cases. Okay? But non-tracking tacks are very difficult to work with. They have a very short shelf life. Most manufacturers will tell you it's 30 days or less. So the days of getting a tanker, pulling it onto your job site, using all the oil all summer long and never refilling that tanker, never heating it, never circulating it, you'll run into nothing but troubles when you're using a non-tracking tack. You got to keep it circulated. So every day or so you need to circulate that material. Circulate it slow. You don't want to beat that stuff up. The more you beat up the emulsion by circulating it in your distributor, the quicker it's going to come apart. You got to keep it hot. Normally closer to 180 degrees on non-tracking tacks. Because that asphalt is hard, you have to make sure that it's soft enough to be able to pump. So trying to spray non-tracking tacks at 120 or 100 degrees is not going to be very beneficial for you. Has a very short shelf life, we talked about, 30 days or so. It doesn't go through your strainers on your machines very well because it is a little bit harder material. So we offer strainers that are a little bit larger hole size to help that go through there. A lot of them have polymers in it, would tend to get caught in strainers and not want to flow through very well. So we can help you out. And never, ever, ever dilute what you purchased as a non-tracking tack. Never dilute it with more water. You'll ruin the product and it will be junk. So here's things to keep in mind with your emulsions and your non-tracking tacks. Keep them at a consistent temperature. Once you get them in that distributor truck, try to keep them at that 150 or 170 degree mark. Don't let them get super cold and then bring them up to hot, cold and hot. Don't cycle that too much. Don't over circulate. The biggest thing there is a lot of job sites that I get on, I will find that an operator sprays a certain amount of tack for the paving for that particular job, and then he may have to wait an hour or two. Well, we don't want to keep that product circulating in that distributor for very long. So if you got to wait an hour or more, suck the system back, leave it in the tank, and shut your pump off. It's not going to get hard in your pump. You don't have to flush it or go through any of those processes, but you just want to make sure we don't over circulate it, because what you'll be doing is shortening the shelf life. Use the tack up as often as you can. Get fresh, okay? So use that tack, get fresh from your supplier, bring it back out. The fresher the tack is, the better it'll work, because we don't want to push that timeline of when Mother Nature is going to win that battle and pull that stuff apart. Suck your system back at the end of the day. Make sure that everything's clean and back out. And because we're using a tack that's an emulsion, we don't have to use very much diesel fuel to clean out our system. Okay? Just a very minimal amount to rinse the pump out, and we're good to go. A lot of people, especially when it gets colder out this time of year, we want to make sure that we don't overuse the amount of diesel and ruin our product. So hot applied is a whole different story. Now instead of being 150 to 180 degrees, we're now 265, maybe all the way up to 400 degrees. Now that creates a lot of different problems. One is if you get it on you, you're going to get burnt. So you got to be much more careful when you're using the products to stay safe with that, okay? Use caution when you're handling the temperature, but also use caution when you're switching products back and forth. Use this as an example. If you've ever been to Thanksgiving and deep fat fried a turkey, okay? If you take that turkey and you lower it in that 350 degree oil and it's a little bit frozen, what happens? It bubbles, it cracks, it pops, it'll blow up that whole thing. The same thing happens is if I had emulsion in my tank or my distributor truck and then I put a hot applied in on top of it without getting all that water out. It's going to turn to steam in about 16 times a second. So, and there's no stopping it. Once it starts turning to steam, there's no turning back. So you have to be very cautious of when you take a hot applied tack and you put it in a distributor truck that has some sort of emulsified or water-based product in it. So just use those as caution Virginia's not using a lot of hot applieds now, but I'm sure they'll be coming in the future. So now what about the application? We talked a little bit about the products, and what I talk about in the products is not real science. It's just general things that I've learned over the years, but a lot of our problems with application is the mere fact that people aren't handling the products correctly. So we got to remember the short shelf life. We got to not over-circulate them. We got to clean units out and get fresh material, because that will affect our application. What we want to see, the ultimate goal, smooth and even all the way across. Just like you took a paintbrush out there and painted the stuff on the surface, that is the ideal tack situation. Adequate coverage from one side to the other. So back in the old days when we could just string it out like this picture, those days aren't there anymore. We have to have uniform coverage, because in any one of those spots where we have no tack, that asphalt's liable not to stick to the base layer, and it's liable to come right back off. So we got to have that uniform application. Same example here. This just shows, if you can see it, plug nozzles. And where are those nozzles plugged? Right in the wheel pass. And that is where most of your truck traffic will be, so that's where we want the most glue, is in the wheel paths. And in this picture we have none. This is even worse over here. You got to have, a lot of this could be caused by operator error, we call it, but this product's probably not hot enough. Okay, it won't flow out of the nozzles because my temperature is too low. Of course, I got some plugged nozzles in certain spots, but most of this is due because I either have the wrong nozzle in my spray bar, or my product is much colder than it should be to spray. Same thing here. This application, if I did the math, in that distance, this application would be correct. The rate that you wanted to shoot is the correct rate, but I did not get uniform coverage. And why is that? It's a simple thing, as we talk about equipment a little later, of the nozzle size in the distributor according to the speed that I'm driving, in order to get a good fan to get that uniform coverage. But don't let the math fool you. At the end of the day, this turned out to be the correct application, but still I'm going to get failed pavement because I don't have any glue uniformly placed on that road. So here's the other picture of the good uniform application. Everything's spraying nice, it's covered really good, but if you notice, what am I missing? Longitudinal joint. I got no tack in my weakest spot on my pavement because the driver has shifted way over too much. Somebody's got to come back in and fill in that spot, or where I want my glue right on my longitudinal joint is not going to be there, and that's where I'm going to get a failure or a pothole, especially in a freeze-thaw cycle. So I want to make sure that we come back in and we shoot that again over there. Even a little more tack there is better than no tack at all. This isn't a uniform application, but it's still better than no tack on the edge of the road. Use whatever method you can to be able to get some of that product out there. What about this picture? This is simple tack on a very dirty surface, and the tack is sitting on top of the dust. It will never penetrate down into the dust. It will sit right on top. It's turned black already, and as soon as your dump trucks drive through it, as soon as your paver goes through it, it's going to end up on all your tires. You're going to be able to follow the dump trucks right back to the asphalt plant because it's going to track all the way out, and you'll be left with nothing but a dirty surface that you're putting your asphalt on, and it won't stick. It'll move around on you. So you got to make sure that surface is clean. And then if you happen to be the general public, you always got to look out for them. But this guy got a free undercoating job by driving down the tack directly behind the distributor. Now, I don't understand at what point when you had to turn your windshield wipers on it took before you figured out you were probably in the wrong spot at the wrong time. So now let's talk about the equipment. Okay, how do we get that uniform application? How do we put it down uniform from one side of the road to the other with the correct application, the correct product, and all that has to come through the equipment? We've been building distributors since 1898. Horse-drawn distributors like this. You'll notice we're up with code in those days. Our horses have boots on them to protect them from the tack that they're putting down. Rollover protection was not incorporated in those days, so we're good to go. But I think the guy at the back end had a pretty long day compared to riding around in an air-conditioned truck these days. So over the years, equipment has evolved. We went to rear engine distributors. Then we went to hydrostatic machines. Now it's computerized, so it's simple to punch in the rate that you want. Okay, but there's still some drawbacks to equipment, some operator finesse that we're going to have to get that uniform application that we're looking at. Whether we're tacking, whether we're patching, whether we're doing full width overlay all the way across the road, whether we're doing a parking lot, it doesn't matter. The distributor components are all the same. It's how we gear our spray bar and our nozzles for that particular job that will make a difference on how we get the uniform coverage all the way across. Then the federal government's idea of a tack truck is a little bit overkill, but this is what they spec. But it'll never get stuck in a soft base. If your base is soft out there, you don't have to worry about getting your distributor stuck. Maybe your paver, but not your distributor. So every distributor on the market has the same basic functions. You're going to fill the tank, you're going to heat it, you're going to circulate it, you're going to spray it in a metered application, and that's what we're after, our metered application. You're going to suck it back, you're going to clean it out, and you're going to go home. That's every distributor on the market has the same basic functions. But it's the metering system that we really want to pay attention to. You have 4 key principles to it. The desired application rate, that somebody's going to tell you what they want for that job. How much tack do I need on the job? Some spray rate in gallons per square yard. And then a forward ground speed. How fast do I need to drive that truck in order to achieve this gallons per square yard? The computers look at all of this stuff all the time. How wide is my shot? Am I shooting 12 foot, 14 foot, 16 foot, 4 foot? What am I shooting for my width? And then what does my pump have to put out in order to achieve my gallons per square yard? All 4 of those things look at each other through the computer continuously. And if any one of those changes at any given time, if I speed up a little bit, my pump will change. If I change my width, my pump will change. If I even change my rate on the job as I'm spraying, it will change my pump also. So all of those things are constantly looking at each other and constantly changing. This is one way to get a uniform application. Sort of a long day, dump some out, squeegee it around, call it good. We want to put it through a truck so we know what we're doing, what we have. We used to use what we called the calculated eye. A lot of jobs over the years I've been on, somebody would spray a little bit and somebody would say, that's not quite enough. Bump it up a little bit, bump it down a little bit. That looks pretty good, call it good. Well, not in today's world. Most places are paying you by the gallon, so you want to make sure that you have the right number of gallons sprayed so you get paid correctly, and the agencies are getting the right gallons that they want on the ground. So we're going to throw the calculated eye guy out, and we're going to use the metered application. Now, if we're doing any handwork, the only reason I put this slide in this presentation is the fact that today's distributors are capable of keeping track of how many square yards you shot, how many feet that you traveled, and how many gallons that you used. Every time you turn the spray bar on, it counts. It does not know what comes out that hand wand. So if you're doing a lot of intersections, this is calculated eye, this is guesswork. You're just looking at it and saying, yeah, that's enough, okay, we're good. But any oil that comes out of that hand spray wand will not be totaled in your computer totals. So just keep that in mind if you're using your computer for your pay item. Everything that we're going to talk about on a distributor is gallons per square yard. They are capable in shooting in metric, but I'm not your guy to talk about metric. So we're going to stick around with gallons per square yard. That's what our application rate is. So here's my 4 things again, just in a picture form. If I speed up, my pump will change. If I change my width, my pump changes. And if I change my rate, my pump will change. All constantly looking at each other, constantly reevaluating so I get my correct gallons per square yard. We take sensors with the radar, okay? We're counting our speed with the radar. When we talk a little bit about maintenance of the equipment, the radar is a crucial part of the machine. If I don't get a good ground signal, it's not counting how fast I'm going, then I'm not going to get the right application rate. So you want to keep this lens clean, you want to keep that serviced well, you want to make sure your radar is in good working order. We have asphalt pumps that have sensors on them. They're counting the revolutions of that pump. So every time that pump turns one time around, we're getting X number of gallons out that. So that's something that we're feeding the computer with as a signal from our pump. But it's all about gallons per minute and feet per minute. Those are the two things that are always being looked at in order to give us that rate. So here's just some pictures of equipment as we've transpired over the years. All of them are capable of putting in the rate that you want. You'll drive a particular speed. Your pump will match that according to the width that you have turned on in order to give us our application rate. We've just changed things over the years, not to dwell on this, just to try to make sure everything stays as simple as possible to try to make any operator be able to run a distributor correctly. But it's all based off the old principle of a slide rule. And what do I mean by a slide rule or a computator? Every manufacturer has one of these, and it's basically a way for us to say what is our width, what rate do we want, and then it will tell us at what speed our pump should be turning. That's what the computer does for us now, but it's another way to double check it. So here's just a quick example. As it moves over there, we're going to pick a speed of 450 feet a minute. So roughly, if I'm at 15 foot wide at 0.04, at 450 feet a minute, my pump's going to be turning 30 gallons a minute. It's just a rough example of how to use the computator. But in today's world, we can use an app. Okay, so we have an app that is available now, free for a download, that will help you on any job. It will let you pick out your bar length. You put in the application rate that you want, in this example 0.08, which is very common of what you're going to be shooting in Virginia. You pick out a distributor speed in either feet per minute or miles per hour. Then, here's the important thing. You have to stay within the range of your nozzle to get a good spray pattern. So we can put in what nozzle we have in that spray bar, and it will tell us what feet per minute is recommended to get this. If I want 12 foot at 0.08, I need to drive that truck between 450 and 844 feet per minute. That will stay within the range of that nozzle. Why is that important? We never thought about that before, but the nozzle only has a hole size. So if I'm driving my truck much faster than the oil that I'm asking it to give can get out the hole, I don't get all the oil out of it. So then two things happen. One is my shot rate becomes light. So at the end of the day, I was supposed to shoot X number of gallons to get a 0.08, and I didn't. Okay? The other thing that happens is your truck gets extremely dirty. The back end of your truck gets all this overspray on it because by overpressurizing the nozzles, we're creating a lot of overspray. So anytime I walk up onto a truck and it's just dripping with oil, I know for a fact that the operator is probably overshooting his nozzles. So we want to pick a nozzle that will give you the speed range that you want. You can vary it. We offer 10 different size nozzles. Our competitors offer 5 or 6 or 7 different sizes. You can plug all those in. Or you can go to miles per hour and just run it off of the speed of miles per hour. Makes it a little simpler. But the app is just your computator in an app form. But let's look at what we're trying to put down. Our minimum rate is 0.05, okay? 0.05 gallons per square yard is only 6 ounces of oil over a 3 foot by 3 foot square. Now we want that uniform coverage. How many times can we talk about that? But how do you take 6 ounces of product and make it go over a 3 foot square uniformly? Very difficult to do. Even if I gave you a paint roller and said paint it out there, 6 ounces of oil is such a little amount that it's hard to get that uniform coverage. So we put a lot of things in place in order to do that. This is my old funny picture I throw in presentations just because it's everything that's wrong with the job. No base compaction, no drainage as you can see, but we are working on the Etnyre non-drip spray bar, and we're still working on it to this day. We've never developed one in 120 years to make one that doesn't drip, so they're all going to drip, but we still are working on it. But it brings us to the spray bar. Everybody's under the assumption that the spray bar affects your application rate. That is incorrect. Any branded distributor out there on the market, you could take the spray bar off of it. You could punch in 0.08 gallons per square yard in your computer. You could drive the correct speed that we want you to go, and you would get the right rate. But it wouldn't be spread out at the width that we want it to be. So the spray bar is crucial in not getting the application rate, but getting the uniform coverage. So there's some things we got to look at. We really want 12 inches from the bottom of our nozzle to the ground. That's where we want to set. We don't want part of our spray bar drooped all the way to the ground, part of it way up in the air. You'll get the right rate, but it won't be uniform across the road. So we want to make that setting correctly. Okay? We want our nozzles set at 30-degree angles. So that way, every fan that comes out of those nozzles isn't touching each other. We don't want high spots and low spots where they're hitting each other all the time and making puddles as we go down the road. So we send this fancy wrench along, which is nothing more than a 7/8 inch wrench, put it on the nozzle, touch the handle to the next nozzle, and it sets you at 30 degrees. Now, it doesn't matter if you're set this way as the picture shows, or if you're set the other way. It doesn't matter. As long as they're all set at 30 degrees, we'll get that perfect triple overlap that we're looking for. The nozzles make a difference also. Years gone by, we had nozzles that we call coin slot. Looks just like a slot. You put a quarter in a pop machine, and away you go. Emulsions tend to grab the surface area of those as they're spraying, and they'll tend to give you heavy edges and light in the middle. So you'll see those string lines going down there. So you'll be heavy, light, heavy, light. Everybody uses a multi-slot, multi-V, V-jet, whatever you want to call it, sort of a football-shaped orifice. So as that oil comes out, it dumps more in the middle and gives you a more uniform spray pattern. So if you have old distributors, and that's what happens with distributor drivers. They get a new truck, but they take all those little things with them from their old truck. Well, maybe they took old coin slot nozzles with them. That will fit in the spray bar, but it won't give them the spray pattern that they're looking for. So we want to make sure our nozzles are consistent. Now, the nozzles are also part of what we call calibration. Don't look at what our rate is. The rate to me is a funky number. Look at the flow. And this is where the app comes in. It takes all of this into consideration. But you can figure this just with a simple thing of, if I pick this nozzle out 7 to 10, you can multiply that by your width, and it will tell you what gallon per minute range you want to read in. We also publish a book that will show you with the nozzle we have. It doesn't matter what your rate is now. Doesn't matter a bit. You have a part number of a nozzle, you want to spray 13 foot wide, it says drive your truck, so my gallon per minute while I'm spraying is between 39 and 58. It just is another way. You can use your speed, you can use your gallons, but either way you want to drive your distributor so you're within the range of the nozzle. That's the hardest thing to teach people, but it's all volume. If my garden hose has the same volume when I turn my spigot on, but in order to make my garden hose spray better or get a better pattern, what do? I put a tip on it, okay? It's just a nozzle on the end in order to get a better pattern. So that's all we're doing with the nozzle inside of a spray bar. Because how every distributor works is a volume coming out of the pump to create a pressure coming out of the nozzle. So you want to make sure that my nozzle is sized correctly for the volume that I'm pushing, okay? That those two things have to work together. So we're taking volume and creating pressure. So we want a flat fan, we call it. So if we have those two things right, if our nozzle's set correctly, we're 12 inches from the ground to the bottom of our nozzles are set at 30 degrees, we get a good flat fan that doesn't touch everything, and it'll look like you put that tack down with a paintbrush because it just lays it right on out. So here's a couple examples of that. Let's say I've got a certain nozzle or I want to drive a certain speed. So my pump is turning a certain gallon per minute. The oil here on the left is the correct application rate, but it's not fanning out like the oil on the right. The only way to do that is to squeeze my garden hose. So I went down in size of the nozzle. I squeezed it tighter to get more pressure so I get a better pattern. The opposite of that is I left my nozzle alone. Again, I have the right application rate here, but it's not fanning out the way that I want it. So what did I do? I had to speed up so that my volume of oil out of my pump sped up also to create the pressure that I needed. Okay, so you have to do it either with speed or nozzle size to obtain the actual spray pattern that you're looking for. One other example of it, 0.05 looks really good. I'm driving 600 feet a minute. My pump's turning 40. I slowed down. My nozzle's a little too big for slowing down, so my pump dropped to 20. I'm still getting 0.05, but I'm not getting the spray coverage that I want. So it all has to do with speed and the nozzle size. So now let's cheat. We talked about perfect setup. We want 12 inches from the bottom of the nozzle to the ground. We want all of our tips on. The computers are really smart, but they're not all that smart. They physically don't know that anything is there. They only know that there's one switch in the cab for every 1 foot of spray bar on your truck. So if we manually shut off some of the nozzles, in this case we use one nozzle. There's 3 nozzles for every foot. So in the cab I got a switch, I got an air cylinder at the back, so when I throw that switch the computer says I need more oil for this 1 foot. It turns on 3 valves, okay, or 3 nozzles. Well, if I've manually shut some of those off and just use one, I'm now getting the same amount of oil but out of less holes, so I get a better spray pattern. I get more pressure. Now we may have to raise our bar up more than 12 inches so I don't leave a gap here, but I can go slower with bigger nozzles and get a better coverage. And why do we use this? Most of the time, if you're doing mainline work, you're going to size your nozzles for your distributor truck accordingly because you can go fairly fast. But now tomorrow I got to go do a parking lot. I got to go real slow, okay? Well, now my nozzles aren't the right size, so I can't get a good fan. So I could, without changing all the tips, I could go back there and flip some of these off and create the pressure I want at a slower speed. Every other nozzle, an example here, I just shut every other one off. I was able to create the pressure I wanted. Probably about 12 inches is still good there, but as long as you're not leaving bare spots, you're fine. But it's just a mechanical way to cheat the computer since the computer doesn't know how many actual nozzles it's coming out of. Here's some pictures of that. This was in a national forest preserve. You had to go really, really slow. Little windy roads through this forest preserve. And of course, the forester says you can't get any tack on any of the vegetation. So we got to stay within the road surface. So we're just idling. So we put a really small tip in and went 1 nozzle per foot. And we were able just to idle along and get that uniform coverage that we're looking for. Now, if I went to mainline on my next shot, I would obviously want to open all those back up because I'm not going to go that slow if I'm doing a mainline paving job. Another example of it, I back along the curb so I'm not getting any up here on my sidewalk, give myself a little playroom, 1 nozzle per foot, my bar's up a little bit, I can then take off and get that uniform coverage all the way across and not have to go very fast to do that. It's inherent that on mainline paving, we could set everything up that will work well at a slow speed, but as soon as an operator sees a lot of road in front of him, even though the paver's going about 38 feet a minute, you're not going to catch a distributor truck, but they feel they got to go 20, 30 miles an hour to be able to accomplish what they want. So we want to size them what works best for you. Everything is flexible. One more picture of it, 1 nozzle per foot, nice even coverage all the way across, but going very, very slow. Because that's what we're after, that uniform coverage all the way across. So the biggest question that I get from being in the industry a long time, selling distributors, forever it seems like, how do I calibrate? The call that I get every year, dozens of times, hey, can you come calibrate my distributor? Well, what does calibration mean? Why should we even check it? Okay, how do you check it? What components are involved? All of that. There is no magic button in the computer system that you punch and say, calibrate my distributor, and it works. Okay? All we're doing is making sure that the mechanical and the electronic components are doing what they're supposed to do. So there's a few things that we want to look at and a few components that come, but how do I check it? The easiest way on a job site to check to see if you're in calibration is to use the measuring stick that's provided with every distributor. It is certified to be for that tank on that truck. So you can take your oil, put your stick in so it just touches the top of the oil, take your reading up here. An Etnyre stick is reverse calibrated, so that will tell you on that line how much material I have in my truck. Then I go spray it, okay? Spray a certain distance at a certain width. Use the stick again. It will tell me, do the math and figure out how much you used compared to the computer. That will tell you if you're within calibration. Now on competitor machines, their sticks are not reverse calibrated, so take their stick, put it all the way in until it hits the bottom of the tank, and then wherever the oil line is in the stick, use it that way, because there's two different styles to that. But want to make sure that every distributor ever made has a calibrated stick for that distributor. So that's the easiest way to check it on the job. Okay? You want to try to keep the truck level or at least at the same plane when you're using that stick. You know, when you're putting it in the manhole, leave it at the same spot. Tanks on trucks are set at an angle a little bit, so we want to make sure if we're checking it at the front of the manhole on our first shot and our next shot, we check it at the front of the manhole also. The other way to check calibration is by weight. Weigh your truck before you take off, tells you how much your weight is, spray your shot, go back and reweigh, do the math, and it will tell you by volume of weight how much product you put on the road. So that's another way to check it. We even make distributors these days that have weigh scales that are on board. Okay, so you can print a ticket out and hand it over. The most common way on most jobs, if you go to NCAT, the National Center for Asphalt Technology, where we do all our paving testing, where they test all these new products and stuff that are out there, they're going to check every shot with what we call a longitudinal rate test. That is nothing more than a pre-weighed pad. We spray over it and then we reweigh the pad, and that will tell us what our shot rate is for every one of those pads. So that's the most common way to check your calibration. It's a messy deal. You're spraying over it. Now somebody's got to pick those up. That's where the college kids come in down at Auburn at NCAT, because they come over and did that for us, rather than us getting all gooey and sticky. But every shot that we did on all our paving segments was not only tested before we went out to the job site, but it was also tested on the job site, and that verified our shot rate. So that's what you want to use for a way to test your calibration. Now, what happens if I'm out of calibration? What do I check? What components are involved? What do I need to look at? We talked about the radar just a little bit. If my radar angle is off, or my lens is dirty, or my pump sensor is not counting the right number of revolutions of my asphalt pump, those are two big culprits that could happen to you. Normally, speed sensors, if they go out, they don't go out of calibration. They either work or they don't work. Okay, so there's no real gray area there. Radars need to be set on the truck frame at the correct angle, roughly 35 degrees. You got to keep that lens clean. You want to make sure you keep the water out. They're watertight but not waterproof. So you don't want to pressure wash these off and try to force water inside that case. But radars can give you a false reading. So there's ways to calibrate. You can double check a radar anytime you want without spraying a drop of oil. Whether your truck is full or empty, you can check to see if your radar, if you wheel out a certain distance, you can check that radar to make sure that it's correct. It's a very simple thing that I would do every year on my distributor truck, is double check your radar. Mechanical components. On an Etnyre, we have a 4-way valve that tells the oil where to go. Competitors have valves that tell the oil where to go after it leaves the pump. If those valves aren't turning correctly, they're all mechanical valves, okay? If they don't turn where they're supposed to, some of the oil that's being counted at the pump is going back into the tank, and your shot rate becomes light. So we all have mechanical issues that have to be checked from time to time. The biggest culprit on a job, especially with non-tracking tacks, is the strainer. We strain the oil before it gets to the pump to try to keep things out of the pump. We don't want to lock that pump up. But if that strainer is full of oil and my pump is counting revolutions below it, but I'm not getting the oil through the strainer, my shot rate becomes light. So you want to check that strainer, especially with non-tracking tacks. I would check it every time you filled up. It's easy to check. You don't have to take anything apart. You can use a flashlight down the fill pipe and be able to look at that and make sure that strainer is clean. Should look like this. Okay? It's got all these holes in it. That oil goes through there and into our pump and then out onto the ground through the spray bar. But if this is all gummed over with a lot of polymers that are in some of our tacks these days, you're not getting the right shot rate because that oil can't get through that strainer. So now what do? My strainer's all gooped up. It's all nasty and dirty. How do I clean it? Simplest way is to light it on fire. Okay? Once you burn all that stuff off, hit it with a wire brush, clean it up, put it back in. How often do I need to do that? I can't tell you how often you get bad product or your product's starting to separate. But if you find where your shot rates are starting to come up light, the first thing I would check is my strainer. The nozzles we talked about are part of calibration also. Do I have the right size hole in my nozzle for the application and the speed that I want to drive? So this becomes part of our calibration. We got to size the nozzle accordingly to get the right calibration. So those are the basic things that come about in your calibration. But here's one of my pet peeves. Okay, everybody's seen this, I'm sure. A guy takes off, he gets a puddle, and then it dribbles, and then it sprays okay. We've all seen that on job sites, and this is what we call operator error. There are ways to make this go away, because this always happens at a butt joint on a paving job, and now you got too much tack right at the butt joint, and people are all mad at you because they got to try to rake some of that tack away. Then I don't have enough in here, so you back up and you do it again. All of this is done with your circulation rate. Newer trucks since 2010 have a thing in the computer to try to eliminate that. But older trucks that out there, if you have a question of that, you need to get a hold of us because we can make that go away with just a simple setting. So the safe operation of equipment and the materials we talked about, two go hand in hand. Don't try to short yourself when you're using a distributor truck, especially with hot products in it. We don't want anybody to get burnt. The scariest thing for me is to pull up onto a job site. Somebody's got the burners lit, we're warming the oil up, and I ask them, what are we shooting? And they have no idea what product's in that tank or how to handle it. So we need to know not only how to handle the products that we have, but also know how to use the equipment that we have. Because we don't want to run into the situation where it's not my job scenario and we run into some of this. In order to do a good paving job, we have to start. The distributor is the first piece of equipment in the paving train. If it doesn't do a good job, the whole paving job goes downhill from there. Etnyre has a website, a lot of information available. You can get the app there, you can use it on the website, all sorts of things that are available, parts manuals, all of that stuff, operation manuals, all downloadable free from the website. We want to make sure that everybody using an Etnyre distributor gets the right information, but we're always just one phone call away too. You can get a hold of us at the factory. And with that being said, we'll see you all later.